Good morning, or good afternoon, I guess at this point. I still feel like I'm on morning time. I was supposed to get in from San Francisco like at 1 a.m. last night, but then my flight was delayed 8 hours or so. So that turned into a red eye on that. So I'm not quite sure what time zone I'm even in anymore. But good afternoon. I hope everyone is enjoying DevNation so far. I'm pretty happy to be here. My name is Tyler Jewell. I'm founder and CEO of a technology company called Codenvy. We're based in San Francisco. We have about 50-ish or so employees, most of them in engineering. And we publish and produce products both for Eclipse Che, which is an open source product I'm going to talk a lot about today, and my company Codenvy, which is also the name of our products as well. So the title of this talk is How to Contribute to a Project in Seconds. And that is really the nature of the conversation I'd like to have. It's interesting, I listened to Matt's keynote talk just a couple minutes ago about containers and Kubernetes, and he had a very articulate way of describing the conflicts that arise between development and operations. And one of the tactics that organizations are adopting en masse to help resolve some of those conflicts that exist is DevOps. And the basic premises behind DevOps is to do things in a highly iterative manner, incredibly frequently, and to do it on an incredibly small scale, such that if you come across any sort of mistakes, it's easy to identify the root cause of those mistakes, and since you're doing things repeatedly, or repetitively, and incrementally, you can just introduce another change that fixes the problem that you've gotten into, and you resolve yourself on the premise that small issues are easier to fix than big ones, and you get into a habitual, iterative cycle there by automating all of that. And we talk about this as DevOps. It's oftentimes called continuous delivery. Agile is a big component of this. But when you factor this in, and we were to take a look at the entire tool chain or pipeline of technologies that you need in order to deliver an application today, it's in 3 buckets. We spend a lot of time here at Red Hat thinking about the technologies they provide to us to host the applications. And there's obviously the infrastructure, the clustering, the storage, the networking, the operating system capabilities, and that's starting to move its way up to the platform as a service tier, and we're seeing offerings between Cloud Foundry and OpenShift, Apache Stratus. And that's a well-defined market. It's under a continual state of flux. DevOps has really evolved into this middle segment. What does it take to deliver those apps? And there is a very interesting workflow that a lot of organizations are implementing in order to have total autonomy from the point in time that the code is committed to the time that the code is actually deployed into production. And all this series of progressions that the code goes through in order to make that ultimate delivery into production. There are some organizations that talk about their ability to go into production dozens of times a day. There are other organizations that are still doing it once a month. My organization, we're able to deploy into production a few times a week. Even though we'd like to get to a few times a day, there are certain challenges to that. But in the process of striving towards that continuous delivery, you bought technologies in those boxes on the bottom: continuous integration, packaging and build tools, code quality, delivery components, whatnot. There's well over 100 firms now that make up that segment. And they don't get a lot of attention, but historically there's also this segment on developing apps. And these are issue management, project management. Gartner would call this the application development lifecycle management. It's a big acronym to embrace all these technologies together. Here's your source code repository. There are over 20 different products on the market that you can provide as your source code repo, and then I don't know how many different IDEs there are. What I'd like to talk to you today about in this presentation is this segment on the lower left called the workspace. And it's an important segment. We don't spend a lot of time talking about it. And presumptively, this workspace is provided within the IDE. And we've never made that disassociation or treated the two separately. But that's a little bit what I want to talk about here today. Now, before we get into this, how many of you are developers in here? OK, almost everybody. Is there anybody not a developer, like an operations professional? You're an operations professional? OK, OK, a couple of operations professionals. OK. For those of you on the developer side, how many of you develop on either your desktop machine or your laptop versus how many of you are developing with terminal services or something remote hosted? For all of the above. Is that everybody in here? All of the above? Some blended mix of it all? OK. All right. And on the IDE front, IntelliJ guys? One IntelliJ guy. Eclipse guys? About half the people Eclipse. NetBeans? Sublime? The guy running the cameras running Sublime. All right. Vim and Emacs sort of all falls into those categories there. OK. OK, good. Let me ask you this. Has anybody in here used a cloud IDE before? Yeah, someone's like halfway raising their hands, right? Yeah, OK. Probably not, because you probably have some sort of fears of it's not going to have the right muscle memory, it's going to be too slow to load, I don't lose my control, all sorts of things like that. We'll get to some of that. All right, so let's talk about this workspace, so now that we've level set. A developer's workspace is responsible for these three phases of the developer workflow. There is the configuration of the project, and we tend to take this for granted. The project tends to be at a source repository like GitHub or Bitbucket, maybe GitLab, whatever, gerrit, depending on what you're using. And you have to have a way of importing that project or in the source code into your workspace and set it up for use. Your projects typically have some sort of type associated with it. Like if you're using Eclipse, it can be a Maven type, an Ant type, a Gradle type. And with that type, it imparts certain behaviors. Now, this is typically done in the IDE. The IDE says, oh, if you are type Maven, therefore I am going to behave differently as the IDE against this project. But there is some sort of type, and there's a setup phase. At some point in time, your workspace is configured, and then you get into what I call the developer cycle. And the developer cycle is the fun time, where you make an edit, you rebuild or redeploy, you run it to test your changes, and you repeat. And you do this repetitively. We'd like to think that we just write a bunch of code, hit save, we do this cycle once, but it doesn't happen that way. It's a very rapid cycle. And the developers who tend to be the happiest are those that have that dev cycle set up in such a way where it's most convenient for them. It tends to be incredibly fast. It tends to be bound to the keystrokes. It tends to, a little bit like a BMW, it anticipates your needs and provides some sort of automation along the way to make that cycle as fast as possible. At some point in time, your project is building the way you want it to do, and then you need to transition it out of your workspace. So you add the files, you commit them to your source repo. If this is maybe like a student project, maybe you're not working with a repository, maybe you just take an FTP, sync it off somewhere with SSH, but you're done and you're transitioning it off. Now, all this stuff requires memory, I/O, storage, right? There are isolation. If you have two workspaces on the same computer, you need to be able to isolate these workspaces so that they don't infect each other and have the dependencies invade. And you also have to deal with the dependencies. And I thought Matt had a very articulate way of describing the dependencies, which is you understand the dependencies that you depend upon, but then there's the dependencies of your dependencies and their dependencies. And all that has to be part of the workspace here as well. And what's interesting is that when we use a desktop IDE, this experience is traditionally not clonable, not shareable, not scalable when we put it all on the single computer there. it becomes a little bit more challenging in that, in addition to setting up your workspace, this workspace has to be integrated with whatever tool of choice that you want to use, right? Because the developer experience has to be delegated and given the authority to the developer themselves. Then there is the tool chain of the organization as defined by the DevOps professionals or maybe management or the CIO's office. So there is the source repository, the nature of your unique workflows, the code formatting, the code quality. All those components have to be integrated in. And then you have your targets, the APIs, the middleware, the databases, the paths that you're working with. And so if you want to have a buildable system, you have to have all these things integrated in. So the workspace is an incredibly complicated thing. And so it's pretty entertaining to me that 95% plus of all workspaces are generally configured like this, which is you get a job, they welcome you to the job, and they say, we'd like you to get started programming. Go set up your workspace. Here's a wiki page. Follow all these instructions. And if you do everything just right, your workspace will be set up. It should be bound to your IDE, and you should be good to go. And it's manual. It's error-prone. Maybe in some organizations, you get to use Vagrant. Anybody in here use Vagrant for? So like I got about third of the people use Vagrant in here as well. OK, so Vagrant is an attempt to take the workspace, put it inside of an image. You can then synchronize that image in some way, shape, or form, and then bind your IDE on top of that. That is certainly a partial solution to the problem, but that image still has its limits. The image is fixed size in terms of RAM and CPU. It is not shareable, meaning in the sense that you can't pair program with users within that image, right? So it's not collaborative in the sense that GitHub makes file editing collaborative. It has to be constantly synchronized. So as the gold standard is updated, the children images have to be updated along with it as well. So there are certain limitations to that. So Codenvy, my company, is building technology to make a developer workspace cloud. And this cloud services two audiences, developers and DevOps professionals. In the case of developers, it's self-service workspaces. There is a web IDE, but particularly these workspaces will work with any IDE. But these are centrally hosted workspaces. They are accessible over API and CLI. And on top of that, there are workspaces that never run out of resources. So, and I'll demonstrate what that means there. And then on the other side, the DevOps side, with DevOps professionals, there's automation so that these workspaces can become continuous. So much the way that you use Jenkins or a Travis CI to continuously build and run your jobs, you can do the same work with the developer workspace. So the developer workspace can be continuously regenerated into a consistent state and then distributed either to a shared pool of users or each user can get their own on a repeatable basis. And this automation happens by treating the workspaces as code, their configuration as code, which becomes versionable and tracked the same way that you track the rest of the technology that's there. So this is the high level of what we do, and I'm going to show some of this stuff. Our stuff is built on top of an open source project called Eclipse Che. Eclipse Che is a relatively new project. It was incorporated in the summer of last year, so it's not even a full year old yet. Eclipse Che is an open source SDK and a cloud IDE for creating these custom workspaces that are there. And they can have custom clients, whether it's a browser client or a non-browser client. And Eclipse Che at this point in time has a lot of contributors coming from Codenvy, but there are contributors coming from IBM. It's now being embedded across all of SAP's products, all their cloud products, and same thing for WSO2 and Huawei as well. So it's got about 50 committers on the project at this point in time, and it's a slowly growing open source project. The big difference between Che and Codenvy is Che is designed as a single tenant multi-user system, and I'll show what that means, versus Codenvy, which is a multi-tenanted multi-user system. And so that's really the only distinction that is there. So how do we do this? How does Che do this at its core? So the first thing is that there needs to be a recipe to define the workspace. Much the way that Docker containers have a Docker file to define the resulting container that needs to be run there, the same thing for a workspace. There needs to be a text file. It needs to describe what projects are going to go in there, how those projects are populated, the typing of those projects, and then where the build and run capabilities are, along with some other policy work. Then you have to have automation to continuously manage the lifecycle of these workspaces. Then there needs to be a way to scale the developer tasks within the workspace, and then a mechanism to enforce corporate policies and measurement of the analytics. So to do that, inside of Che has a incredibly rich and opinionated entity model that represents that developer workflow that I talked about, the edit, build, run cycle. And it's represented as a RESTful set of APIs. And those RESTful APIs represent most of the atomic functions that you would need to do within that workspace itself. And as a result, they're all implemented and deployable as microservices, where those microservices are backed by a set of independently deployable machines. So there can be machines that are responsible for the content assist of a project, which are different than the machines responsible for the build or the run. And so at runtime, you are connecting with some IDE. The developer is performing some task, run unit test, clone source code, build my code, and it maps down to these machines, which can then be distributed onto a variety of different nodes. And so what ends up happening is that the developer is presented with a very traditional IDE-like experience, either through his traditional IDE or a browser client, but he's gaining access to a supercomputer full of resources behind the scenes that never run out, because the system is taking care of mapping each of those individual tasks onto the nodes that are best suited to servicing them. And because all this is done on a hosted developer workspace, there are ways to plug in the rest of your tool chain automatically so that when the workspace exists, that workspace is plugged in there. So that's enough talk. Let us hope that the internet is not even connected now. So there we go. I've barely even gotten started, and Murphy has already shown up. Yep. Well, I've been connected. You've seen my Skype messages pop up while we were. What's that? Oh, this one here?
No, fast. It's not showing up right now. Anyways, it has fewer users than.
Which one was that? Let's see. Now I'm connected again. There we go. All righty. OK. So what I'm going to do is I'm going to start with the most simplistic of examples here. I'm going to start with Codenvy, and then we'll work our way through a bunch of different examples that are there. So here I am in Codenvy. This is a user dashboard. This dashboard is written in AngularJS and JavaScript, lightweight running. You can see that it's running at codenvy.com. I'm just going to go and create a new project. This is now opening up our IDE. We have a thin client IDE. Our design inspiration for this IDE is influenced by Sublime and Eclipse and IntelliJ pretty heavily. But I'm just going to come in here, and I'm going to grab a sample. Let's grab here's a Spring sample down below. Let's call this DevNation. We'll make this a public project here. I got to zoom out, create, zoom back in. All right. So it's now creating the project. And what's interesting is that when you're dealing with a hosted workspace, not only when you create the project, not only do you get the source code as well, but it has to import the entire environment along with it. So this is usually instantaneous. So this finishing editor initialization is a reflection that there's some sort of latency or lag between our system and the server there. But what it's done is it's created the workspace. You can see, and created a project inside of it. At the top URL, you can see that my workspace is Tyler Jewell. I'm logged in on my workspace. My workspace can be shared with other people. I can give membership to other people. That can be public or private membership. They can have very particular roles and access controls on what they're allowed to do. And we've created a project here called DevNation. As part of that project, it did a clone of source code from GitHub. This is a particular Spring project that is there. And, all right. Yeah. You guys have any ideas? Is there like another network I can get on by any chance?
There's one called Fast, but I think it's 45G.
There's a Heinz staff. No, it doesn't even show it. I probably have to type in the SSID direct on it. Is it a secure? It's broadcasted? All right. Really? Oh. Yeah, sure. By all means, yeah.
So if you were using this, I mean, what do you do like you're traveling? You don't have access to the internet?
There's an offline mode as well. But the offline mode, you have to first have the hosted workspace, and then you sync the workspace offline, and then you can use the workspace in an offline mode. And when you're connected again, it syncs back on there. That's one way to do it. We have plugins for the Eclipse. Like the Eclipse IDE itself, that will not work in an offline mode, right? So that plugin is actively integrating with the APIs and interacting with that remote workspace that's there, and it's taking care of the sync mechanism, importing the project into Eclipse and treating it that way as well. This is a total bummer. Let's see here. So how can we? Okay, thank you. Toad. What's the name of that hotspot?
So Matt's iPhone 6, whatever.
I didn't see it connect.
There you go.
Here we go. Okay. And Toad. Is that Toad like as in the DBA product?
Well, you know.
Sorry. Everybody, yeah, change it out. Thank you. We're getting some free iPhone 6 connectivity saved by Matt. Matt gets some free kudos here. All right. Let's see if this is gonna. See if this is gonna play nice with us. No, Joy, not yet. But let's see here. Sometimes you just have to. Yeah, I can do that. If first of all, most of this will work on anybody else's laptop. Let me just try that. Is yours working good?
All right.
See, this is the true portability. Let's see how, if it works fine on his machine argument, right? That's collaboration right there. All right. That is not, sir, how we spell our company name. One too many E's there. There we go. Let me log in. Yeah. Nice. Look at this. This is awesome. No. All right. So there's our DevNation. Let me see if we can zoom in here. All right. This actually is, what are you using? Is this the fast? This is awesome. Okay, awesome. Okay, so here we go. The file is opened up here. It's interesting. Let's see, what is this? What browser is this? This is Chrome? Okay. All right. All right. Okay. Okay, so here's a Java file. It's in here. Within this Java file, it is being processed on the server side. There is syntax highlighting. There's very rich content assist. Actually, in our 4.0 release, which is going to come out in the second half of this year, we're going to have all the same content assist support that is in Eclipse. So, and it's all done on the server side and processed in a multi-tenanted way. So all the autocompletes, all the refactoring capabilities, all the annotations, all the content suggestions, they'll all be in there. So you can come in here, you can knock this off, and you can see that the file was automatically saved. That file was saved on the hosted workspace on the remote side. The abstract syntax tree was processed. We've got an error code there. I can put this back in. So lots of capabilities. You have a selection of editors. In this case, we're using both Orion and CodeMirror as editors in here. There are outline capabilities. There's a built-in debugger on this. There is code refresh, code management, and all this stuff is handled server-side, and then there's a very thin, lightweight protocol to embed this in the client that's here. Where this gets interesting is, let's see, did the build run already? Not yet. So you do a build, and in this particular project, it was defined as a Maven project. It detected that as a pom.xml. So the workspace on the server side has been registered as Maven. The Maven plugins have been added. Plugins I'll talk about a little bit here, but they can be both server-side within the workspace and also client-side within the browser. And in this case, Maven needs to execute the Maven clean install, and it downloads all the dependencies. We showed that previously when it had locked up. It had already got the dependencies from the internet, and it has completed the build. When it comes time to do a run, the workspace also needs to provide the resources to do the run. So much like on your local host or in your Vagrant box, on the remote side, when you say run, we create inside a Che another environment, and we use Docker to create this environment. And so we're spawning up another container. That container recipe is attached to this project. After the container has been built, we then take all the source code of the project and inject it into the container and all the artifacts. So in this case, it's got a WAR file, and they're all copied in. And so if I were to come over here to the properties, this is, I'm sorry, sir, I'm going to minimize this, if you don't mind. Thank you. There we go. This is the Docker file that was used to create that runner environment that's there. And so it's pulling from a base image, which is JDK7 and Tomcat 7. It sets a very simple environment variable, and then sets the volume, which is just a way to tell us where to put the WAR files when they're copied in here. The runner was started. you can actually go back through the history. You can see that this is thus creating the Docker container, right? And it's successfully built. And then after the Docker container is done, it runs a command, which is basically starting Tomcat. And then after Tomcat was started, there's a URL here, which is our runner, and there's that Spring project that is running for you. And even though we had to swap machines, this is actually the demo I wanted to do. We didn't have to install. You're not a stunt double, correct? We have not installed anything on your machine prior to this. We just load it up and run. And here we've got this project without having to install any sort of software. This basic thing right here was a vision that I had starting about 5 years ago. So a little bit about my background. 15 years ago, I wrote 3 books on Java. I was working at BEA. I was having a good time. I was very technical. I was a lot like Arun Gupta. And I got greedy, and so therefore I went into management thinking I'd get paid more. I got promoted a couple of times, hated my life. And about 2010, 2011, I got sick. When I got recovered from being sick, I said, geez, I want to reacquire my technology skills. I miss banging on the keyboard, playing with code, writing about it. And at the time, technology had moved on. Maven did not exist when I was playing with technology. I was dealing with stuff like EJB 1.0 and 2.0. That's how old I was, dating myself there. And so I tried to get Eclipse with Tomcat, I think it was 6 at the time, and the Pet Store app. And it took me a week, and I could not get this technology to work together. So you had the most common application server on the planet with the world's most popular IDE with a very popular getting started project, and I couldn't get it to work on MySQL. And it was just so frustrating to me. And so the basic vision was we should be able to go to any project on the planet, and there should be a URL there. And you should be able to click on that URL, and within that URL is all the instructions that we need to recreate a perfectly workable environment so that you can edit it, build it, run it, make changes to it, and then contribute those changes back. And you shouldn't have to do anything as long as you have the right privileges that are there. So this is a very, very basic example of that. So I'm going to kill this here, and then I need to think about, let's see, I'm going to, an incognito window, and then I need to go to github.com. I'm going to do another example here. Now we're in an incognito window, so definitely not even logged in now. Sorry, let me pull up so I get the right URL. Demo, GitHub, Codenvy, demo, Spring Pet Clinic. All right. Here we go. OK. So here's that very frustrating example that I had from many years ago. Here's a Spring Pet Clinic. This particular project not only requires Maven, but it requires Tomcat 8 and MySQL as well on top of that. So in this example, I'm logged in as incognito, so I'm not signed in anywhere. In this case, we've taken everything and we've packaged it up into what we call a factory. A factory is a URL. In this case, it's got a button in front of it. But that factory URL was generated off of a recipe that we wrote. And the recipe is just JSON. We can show you what it looks like. But the recipe basically says, create everything from scratch. And it has the entire information of what needs to be in there. So when I click on this, great. It's going to ask me, it's a private repository at GitHub, so I need to have the right credential. Good. OK, so I had to authenticate with GitHub there. But now, after I got the right permissions, it's going to clone that project, but it's also putting it up in a temp workspace because it doesn't know who I am. Right? So up here at the top, you can see that it's a temp workspace. a pop-up block up here. Yeah, okay, done, good. All right. And do this one more time because we have a pop-ups blocked. So you can see that there is a temp workspace by the ID up here, so it doesn't know who I am. What makes it temporary is that if we close this browser tab, we're going to lose all the work. The workspace will be thrown away. It's cloning the source code over there. It's getting the full project set up. And and it's downloaded all the dependencies there. And we're out of RAM. So, because I did a rerun on this. How do I? It's not going to let me pull this up, is it? All right. All right, we'll try this. Now that we've got our pop-ups enabled the right way, we'll start from scratch with the new temp workspace. There we go. Authenticate with GitHub. Create temporary workspace. All the RAM we need will be there. What's that? The memory, it ran out of memory because I ran the same workspace twice, and so the first workspace actually used the memory, and then when I refreshed it, it had a zombie session there, and I had to rerun it the second time because your pop-up blocker was stopping something, so I turned that off. But now we're good here. So in addition to this, without me having to do anything, it auto-programmed to build, it auto-programmed to run as well inside of this recipe that's here. And in this particular recipe, I'll pull up the properties here. This is a Docker file that starts from the same one, but it downloads Tomcat 8. It opens up port 8080. It sets some additional environment directories. Here's the working directory where Tomcat's going to be. It's going to take the WAR file that was built in the previous step and put it into the working directory. And then it's going to run Tomcat there. And that's exactly what it did. It gave us a URL, and there's the Pet Clinic project running on top of MySQL without having to install anything. And so from the time that we clicked that link to the time we got here, it's approximately 45-ish seconds to the time where it's running. Now, in addition to this, we have mapped this because we came from a source repository. It knows the source repository that we started at. So I can come in here, I can make a change, and because it knows exactly where we came from, I can issue a pull request. And so what it's doing here is it first created a local clone in my workspace on a hosted basis. It then created a branch in that local clone. It added the file, committed the file to that local branch. Now, if you want to issue a pull request to GitHub, on top of that, the API work to GitHub is going on there. On top of that, it then connected to my GitHub account, created a fork of that repository into my account. It's pushing the local branch from your local clone onto that remote branch. And then once the fork is updated with the branch that has the change, it'll issue the pull request onto that branch. And so this is going to spin along, and it's waiting for it. There we go. It's all gotten done here. So it pushed the branch onto the fork, issued the pull request. And if I go here and click Open on GitHub, pop-ups block again? Ah, thank you. Good catch. So now here's the pull request, and inside that pull request is another factory link, but this factory link has been encoded not just with the previous project, but the previous project with all the changes inside of it. So if I was a reviewer of this pull request and I need to accept it or reject it, I can click on that, and now a second workspace has been created. This is a workspace for the project reviewer. It's completely isolated from the first one, and this workspace has all the changes that were embedded inside that pull request, and I can build it and run it to see whether I want to accept it or reject it. And to test that out, we can open this up. That's the markdown, and there it is. This is DevNation, right? So what did that workflow show? We started with nothing because we're in an incognito window in Chrome. There is a factory URL that has a recipe to define that workspace. That workspace has a definition of what the source code is to get, all the authentication credentials against the remote repository, along with the builders and the runners that are necessary to perform the work within that workspace. We made the change, we committed it, we did a pull request, and then the person who reviews the pull request gets their own workspace with those changes, and they can accept or reject it here. All right? So, so when this all comes together, this is a company, Youth Digital. They make programming courses for kids as young as 6 years old. They teach kids how to program in Java by teaching them how to modify Minecraft. They teach Minecraft modding here. It's an incredible company. They have this server design course, and in this, here's one of those projects, and what they did is they actually took Codenvy and Che, and they're running on their own a white-labeled version of this. They still have a little bit more work to do, but they've gotten rid of most of the Codenvy branding elements here. And this opened up, used the factory capability to open up a new workspace here, and it's actually got a Minecraft server running inside of it. So this is, if I open this up, this is a Minecraft server here, and if I need to, I can come and run, and this is actually launching a Minecraft server. If it had been on my other machine, I actually have Minecraft, but I can actually open up Minecraft. When this is all said and done, I can plug in the URL that it gives here, and I can actually play this Minecraft server. So they use this, they have these video instruction, they teach kids about certain language concepts on how to modify the game. The kids come into here, make their modifications, save it into their own personal Minecraft server, and then they use their own Minecraft clients against it to play the game that they just modified on it. So it's a great course, and it's pretty responsive. But this is an example use of the technology out in the wild here.
There's a server running for Minecraft in that instance. Is it like a container runner?
Yeah, it's right here. Yeah, so this is a Docker container that is run. So they're running a Codenvy cluster, right? And inside of that Codenvy cluster, there's a run microservice. And the run microservice is managing a Docker cluster. So each run event gets a Docker container that is managed by Codenvy or Che in that regards, right? And each one of those containers gets their own URL. In this case, they hide the URL, but you can see that tylerjewell.youthdigital.me. If somebody happened to have Minecraft on their computer, you could actually go into Minecraft and say connect to a server, put that URL in, and it will connect to the system there on that. So, sir, thank you. I'm going to switch back to my laptop, which has the slides on it. That was awesome. Showing the power of nothing installed. Actually, we can do it in 5 minutes if you'd like. You can hope. So that's what I was going to wrap up with. So. So what's the difference between Che and Codenvy? Control L. We've seen all these great examples. So Che, at its heart, right, is structured architecturally like this. At the lowest level, there are machines which are running Docker containers or operating system processes, and you can customize those. And those machines can be attached to particular microservices like build, run, whatnot. On top of that, there are Che REST services that are represented as APIs. You can customize those by writing Java extensions. So there is a very simple annotation format. You can write those, you can deploy those into Che, and you get entirely new microservices. If you want to use our Cloud IDE, you can do that too, and you can modify that. We write that in GWT, and so you can write a GWT extension, deploy that in, and it can completely customize the UI. You can change the look and feel, you can change the menus, the windowing, and do whatever you want. Or you could just bypass all that, have your rich clients connect right down to the REST services as well. The difference between Che and Codenvy is that Che is a single tenant system. Multi-user, meaning you can have many users hitting the same URL at the same time, but it's a single tenant. And Codenvy takes that and makes it multi-tenant. So you can have many accounts. There is a user database that's embedded. There's analytics, and there's elasticity built in on it. We don't have time to go into those details. Where's the? I don't have that great graphic. Okay. So to get Codenvy, you have a lot of choices. So one, you can install Codenvy cluster using a bootstrap script, and you can install it as a single node on CentOS, or you can install it as a multi-node. The only thing that Codenvy requires is that you give us a pool of CentOS nodes. And so you give us the DNS names of those CentOS nodes, and then you say install Codenvy, and we take care of installing everything. We treat it as a closed system. We install all the software that's necessary onto that and deal with all the upgrades, backup, recovery, and the healing nature of that as well. If a bootstrap is too complicated because you don't want to wait for the internet to download, I mean, it's a pretty big install, we also provide Vagrant and AMI installations of the single node as well. And so you could go to Amazon right now, look up the Codenvy AMI, and that'll install in about 2 minutes. And that opens up, and inside of it is running an entire multi-tenanted Codenvy cluster there on a single node. And it's production grade. And you can take any Eclipse Che extension you want, deploy it into Codenvy if you so see fit, or you can just take Eclipse Che, customize it however you see fit, and deploy it. Eclipse Che is commonly used at SAP. They're using it as embedded workspaces for their cloud products. So they will ship a cloud product. Inside of it will be Che. There will be an administrator who needs some sort of development environment. They click a link, and a Che instance opens up. Each user gets their own Che instance in that regard. Same thing for WSO2. They're embedding it in their ESB and server-side products as well on that. So that's the distinction. In the Vagrant box, you can get the same experience with that as well. All right. I think we have about 5 minutes. We came here to this conference. We're trying to drum up more participation in Che itself. So there is the source code. There is a developer mailing list. It's very active. There is a lot of dialogue and conversation that's going on with that. We also have weekly open planning meetings. Anyone's welcome to participate in that. And we also hang out in IRC and on Slack. We've got about 1,000 issues open on Che, so there's a lot of work to be done. Unfortunately, they're not public. We're still working with the Eclipse Foundation to figure out how we migrate all these issues out of Jira into Bugzilla. Last but not least, for those of you, this is what the source code looks like in modifying a Che extension. It's pretty simple. There are classes. We use dependency injection. We have some custom tags there. You follow that convention, and you end up being able to modify the system itself. Che ships with about 55 plugins, so there's tons of examples. So you can take Che, you can run it, you can see how all the extensions have been built at this point in time, and copying and pasting is the best way to kind of learn on your own. We do have a little bit of work to do on making our Che examples a lot prettier, unfortunately, so we would encourage you to file tickets or discuss on the news group if some of the examples aren't exactly what you're looking for. But it's a big area of focus for us in the second half of the year. I think we're going to be doing kind of a complete example overhaul on that. So I'll pause there. I think we got like 5 minutes left. Is there any questions?